Okay, hi folks. This is for Statistics 1, the continuation of Chapter 7. Where we left off was in Section 7.4, finishing up the expected value, variance, and standard deviation of a discrete random variable. So throughout these, since I already sent you all of these notes, I'm going to be making comments as we go along here. The work is already done. Obviously, if you need to stop this and jot anything down on your notes, you certainly can do that. This won't be just me sitting here reading all of this stuff. But anyway, what we're doing here is a simplified investment portfolio example. We've got two different portfolios. The annual return on these portfolios, meaning basically how much you get back at the end of the year, is given in a simplistic form here. So X is portfolio 1, Y is portfolio 2, and you can see the different values in terms of the annual returns. For X, it's negative 300, 0, 200, and 1,000 with its corresponding probabilities, and for portfolio 2, it's negative 3750, 0, 500, and 5,000. If you calculate the expected value or the expected annual return, in both cases the value is $200. So as far as these two portfolios are concerned, they have the same expected return. Remember, the expected value, we're taking each value of the variable, multiplying it by its probability, and then adding those up. So they have the same annual return, $200. And the question then becomes, if we had to choose between the two, which one would we invest in? So this is going to be kind of clumsy because I don't have my tripod, couldn't find it. I have a feeling it's up in my attic, so I'm just going to have some changeover time here. So anyway, some things to note about the two portfolios. In the case of portfolio 1, it has a smaller probability of losing money. That would be a negative return, 0.1 versus 0.2. In portfolio 2, the highest possible return is $5,000 versus $1,000 in portfolio 1. And as also mentioned here, portfolio 2 could result in a much larger loss than portfolio 1. So what we're going to calculate here is the corresponding value of the variance of a discrete random variable. What you can see there is the formula for sigma squared. Similar to, but not the same as the formula for S squared. We're taking each value of X, we're subtracting the mean, we're squaring that quantity and multiplying it by its probability, and then adding them up. So I've written both of these out here. I'll go through the formula for portfolio 1. Remember that the mean was $200. So the four values for the return were negative 300, 0, 200, and 1,000. And as you can see here, in each case I've taken that value, those values, and subtracted 200, squared that quantity, and multiplied by the corresponding probability of each return value. So if we go through that entire process, you'll notice that this adds up to 135,000. For portfolio 2, it's slightly over 6.6 million. Remember, those are the variances, so the units are squared in such a case. So what we would end up doing is taking the square root of each one, and it appears that I have my pages out of order. Sorry about that. Hang on a second.